What if I told you that deep beneath the surface of Mars, something is hiding? Something scientists still don't fully understand. Is the red planet truly lifeless? Or could something still be surviving beneath it? And those recently revealed surface signals, are they just natural formations? Or could they be clues pointing to something far more mysterious? Stay with me until the very end, because what you're about to discover might completely change how you see Mars forever. And hey, if you're someone who loves space discoveries, but also enjoys finding smart gadgets and useful online products, make sure to check the link in the description. You might find something worth exploring. Now don't miss a single second, because things are about to get intense. If you enjoy this kind of deep and mind-blowing content, make sure to subscribe, share this video, and drop your thoughts in the comments below. A silent world, a frozen mystery. The red planet holds secrets far deeper than what we can see, and its story begins now. Welcome to All About Mars Surface, episode Hidden Realms Beneath Mars. In this episode, we go beyond the surface, beyond what cameras can capture. This time, we're diving into a hidden world, a place that remains unseen, yet holds some of the planet's greatest mysteries. At first glance, Mars appears cold, dry, and lifeless, a quiet desert frozen in time. But beneath that still surface lies a complex and dynamic system, one that tells a very different story. The outer layer of Mars is covered in fine dust, sand, and broken rock fragments. This layer is known as regolith, formed over billions of years through powerful dust storms, extreme temperature shifts, and countless impacts from space. But just beneath this loose surface lies something far more ancient, a solid crust made of hardened rock, preserved for billions of years, holding the deep history of the planet. Scientists now believe that beneath this crust, Mars contains vast reserves of frozen water. In many regions, this ice is trapped just below the surface, protected from sunlight by only a thin layer of soil. Using advanced radar systems from orbiting spacecraft, including missions by NASA, scientists have been able to scan beneath the surface. These radar waves penetrate the ground, reflect back, and reveal what lies hidden underground. And what they found is remarkable. In colder regions, especially near the poles, this underground ice forms thick layers that extend deep into the Martian crust. These frozen deposits are believed to be remnants from a time when Mars had a warmer and wetter climate. Over time, as Mars lost much of its atmosphere and cooled down, liquid water disappeared from the surface. What remained became trapped beneath the ground in the form of ice. But here's what makes this even more fascinating. This underground ice doesn't just sit there. It actually shapes the surface above it. In some areas, the ground appears smooth and slightly raised. In others, you can see cracks and unusual patterns formed by the expansion and contraction of frozen material. These formations act as clues, helping scientists understand what's happening beneath the surface. But an even bigger question remains. Could liquid water still exist on Mars today? On the surface, the conditions are too extreme, temperatures are extremely low, and the atmosphere is too thin to support liquid water for long. But below the surface, conditions may be very different. All About Mars Surface brings you another deep dive into the red planet. This time, we turn our attention to one of the most intense natural phenomena on Mars. Its enormous dust storms, capable of reshaping the entire planet for weeks, sometimes even months. These storms rank among the most powerful and visually striking events in the Martian environment. Though they may seem subtle at times, their long-term impact on the surface is significant and ongoing. Mars is famously called the Red Planet, and that signature color comes from the fine dust blanketing much of its surface. This dust is made up of tiny fragments of iron-rich rock, gradually broken down over billions of years. When sunlight hits these particles, it reflects a reddish-orange glow, giving Mars its iconic appearance. Despite having an atmosphere much thinner than Earth's, Mars is still able to move vast quantities of dust. Even relatively light winds can lift particles off the ground because they are incredibly fine and lightweight. Once airborne, this dust can travel across great distances, sometimes spanning entire regions of the planet. Dust storms on Mars often start small. Uneven heating from the sun causes warm air to rise, while cooler air rushes in to take its place. This movement generates wind. In areas filled with loose surface dust, these winds begin to lift particles into the atmosphere. At first, a storm might remain limited to a small region, but as dust accumulates in the air, it absorbs sunlight, warming the surrounding atmosphere. This added heat causes even more air to rise, strengthening the winds and allowing the storm to expand. Over time, what began as a minor disturbance can evolve into a massive atmospheric event. Many storms remain regional, covering large sections of the planet, often stretching hundreds or even thousands of kilometers. From orbit, they appear as vast, swirling clouds of reddish dust, slowly drifting across the surface. Occasionally, multiple storms merge together under the right conditions. When this happens, they can grow into planet-wide events known as global dust storms. During these rare but powerful occurrences, Mars can become almost entirely enveloped in dust. When a global storm takes hold, sunlight reaching the surface drops dramatically. The sky turns dim and hazy as thick layers of dust fill the atmosphere. From space, familiar landmarks can vanish beneath the dense cloud cover. These storms also have a unique effect on temperature. While the surface cools due to reduced sunlight, the atmosphere actually warms because dust particles trap heat. This imbalance alters atmospheric circulation and can keep storms active for extended periods, sometimes lasting weeks. Eventually, as winds weaken, the dust begins to settle. But Mars rarely looks the same afterward. Fresh layers of dust may blanket certain regions, while other areas become exposed where winds have cleared the surface. Over time, this constant shifting gradually reshapes the Martian landscape. In addition to large storms, Mars also experiences smaller phenomena known as dust devils. These spinning columns of air move across the surface, picking up dust as they go. Though much smaller than major storms, they are common and play an important role in redistributing dust. Dust devils often leave behind dark streaks on the surface by removing the top layer of bright dust and revealing darker material underneath. These trails can stretch for kilometers and are clearly visible in images captured by orbiting spacecraft. Dust activity also presents serious challenges for robotic missions. Rovers powered by solar energy rely on sunlight to function. During intense dust storms, reduced sunlight means less power, which can threaten mission operations. In one well-known case, a powerful dust storm blocked sunlight for so long that a rover was unable to recharge its batteries. Communication was eventually lost, bringing an end to a mission that had far exceeded expectations. Interestingly, dust can sometimes work in favor of these machines. Passing dust devils have been known to clean solar panels by blowing away accumulated dust, temporarily boosting power levels. These natural cleaning events have helped extend the lifespan of several Mars missions. Understanding these storms is crucial for future human exploration. Large-scale dust events could reduce visibility, code equipment, and disrupt solar power systems.